Again, I'm sorry we're late getting started. I should have done this before I started Screencast-O-Matic, but do y'all know about the deadlines? This EWI, Executive Women International Assist, which is adult students in a scholastic transition scholarship program. The application is due this Friday, the 28th. Okay, so it's not a trivial application. It's not super long, but it is several pages. So I would suggest, if you're interested, get started. Hopefully you already started, but be working on it. Get it done this week early, so you can get all the things done they need. And then there's April scholarships. These are not those, but they have them down in Financial Services office. You're certainly welcome to pick one up. And they should have May's out pretty soon. All right, any questions on anything we've done so far? I'm lost here. I have my book here. We're in chapter 4, section 4.4, undetermined coefficients. And it's the superposition approach is what we've been doing. Before we get going on that, let me make these announcements, which I did include to have on Screencast-O-Matic and YouTube. The student course evaluations are open now, and you said you had done yours, okay? And oh, good, okay. So be sure to get it done. Huh? Oh, fantastic! Thank you. Just get it done before the end of the term. I knew the Silvas are leaving early, so I wanted to make sure she remembered got hers done, but she showed me she had done those. So thanks for getting them done. And we will be, and I think they also want you to vote for Student Government Association. That's what that was, right? Officers then, which is pretty important too. Okay.
I just picked the name.
Yeah. I think I've only seen one poster on this campus. I haven't seen that many on the Birmingham campus, but I've only seen one here. But I'm sure there's some more, but I saw a few more on Birmingham campus. Okay, any questions on anything we've done up till now? Okay, we're, like I said, on Chapter 4, Section 4.4, undetermined coefficients. Chapter 4, by the way, is higher order differential equations. 4.4 is undetermined coefficients, the superposition approach, and we're on page 142, example 4 at the bottom of the page. And an unfortunate title for this example, but I won't read the title, we'll just do it. Find a particular solution of this. Let me get my pen color chosen, okay. Y double prime minus 5y prime plus 4y is equal to ae to the x. Now, what would you suggest we do first? Yeah, actually one really small step before you do that. Second? Okay, the derivatives are taken. We will be taking derivatives in a bit, but what's the first step to solve that? Okay, yeah. This may not be the right way to express it, but the left-hand side had all your y's and y primes on them. Your right-hand side has all the functions of x's, okay? Now, these have some constant functions there. Those are easy to deal with, relative. So, instead of equal to the function of x, set it equal to 0. That's set the homogeneous equation. And that is when, so that's the first thing we'll do. Y double prime minus 5y prime plus 4y is equal to 0. Now what do we do with that? That's what De Silva was talking about. What's that? Yeah, okay.
And what would be the M equation? M squared M plus 4 equals 0. Now that, in this case, is called our characteristic solution. If that had been a homogeneous equation to begin with, this would be our solution, or the beginning of it anyway. But this is now called our characteristic solution. Okay, and what do we do with that? What's the F word? Factor it. Okay, does it factor? We hope. M and M, got it. Minus and minus. Not 5. 4 and 1. Got it. And that works, doesn't it? M times M is M squared. Minus M minus 4M is minus 5M plus 4. Yes, that works. Okay, then what? M is equal to 4, or M is equal to 1. And what do those represent? Say what? Okay, M1 and M2, we can call them that if we like. And what would that give us? Our characteristic equation, which is y sub c is equal to, yeah, and you set a constant. I'm going to do a C1 e to the, you're going 4x, okay, we'll do that, plus C2 e to the x. Now, they may have their C1s and C2s reversed and whatever. We don't really care that much, do we? Okay. So that's our characteristic equation. Okay. Now, what typically would we have done from here? Any hints or suggestions? Yeah. In other words, the particular solution. Okay? So we're going to look for the particular solution. Y sub p. Now, what form would you guess it would take? And I was trying to find where they first introduced it to us. And I guess we'll go back to the top of page 140 when it says the g of x is either a constant k, a polynomial function, an exponential function, a sine or cosine function, finite sums or products of any of those functions. So which of those would seem the most likely to be a particular solution? An exponential function. And the exponential function you would think would be e to the x, because if you have any e to the 2x's or 5x's or anything else, not going to ever get you an e to the x. Okay? So what would you choose as a particular solution to go with? Y sub p equal to some maybe constant like capital A e to the x. I mean, I don't see that a polynomial function is going to help you any. A constant is going to help you any. I mean, you could have maybe a constant plus, well, no, it's a constant k, polynomial function, exponential function, sine or cosine function, or a finite sums and products of those functions. Okay? Now, maybe a finite sum, like k plus a, or a plus, or a e to the x plus b, or something like that. But you know, well, anyway, what happens if you use that as a particular function? Your particular function is your first guess anyway. You would probably want then to go and take your derivatives. So yp prime would be a e to the x, and yp double prime would be a e to the x. And if you plug those in up above, you would have a e to the x, that's for your y double prime, minus 5 a e to the x, that's for your y prime, plus 4 a e to the x. And that would be, you would want to set it equal to 8 e to the x, wouldn't you? Okay? Now, you could divide out all the a to the x's, e to the x's, because they are the same on both sides. And then you would have a minus 5a plus 4a is equal to 8. And that would give us 0 is equal to 8, which usually doesn't happen in this universe, does it? So guess what? We're not doing too well. That's why they call this a glitch in the method. So how do you think we're going to unglitch this method? Now, they left the e to the x's in the 8e to the x, but yeah, doesn't. So clearly we made the wrong guess for yp. The difficulty here is apparent on examining the complementary function because you already have e to the x in that. Okay? Observe that our assumption a e to the x is already present in y to c, the complementary solution. So this means that e to the x is a solution associated with a homogeneous differential equation, and a constant multiple, a e to the x, when substituted into the differential equation, necessarily produces 0. So what then should be the form of yp? So if we go back to case 2, where was that? That was in a previous section, section 4.3, the last section, case 2. Remember when you had two distinct real roots? What you did then was multiply 1 by an x. Remember? No, I'm sorry. Case 2. Related, repeated real roots, multiply 1 by an x. So that might be our solution here. Try putting an x in there. Okay? Of course, that's going to complicate lots of other things like your derivatives, but we need something a little complicated because everything went to 0 except a e to the x, which wasn't going to be 0. Okay? So let's see what happens if we do that. Okay? What will yp prime be then? You put an extra factor of x in there. Okay, ax e to the x. Now what he did was product rule, the product of the derivative, the first function times the derivative of the second. So then the second part will be plus a e to the x, which is the derivative of the first function times the second. And that would be a e to x. Got it? So now we need to do our yp double prime, because we need that up there. What would that be? A x e to the x plus, right, plus another one, so that makes two of them, right? So there we have our y double prime. So now let's plug into the original, and we have a x e to the x plus 2 a e to the x minus 5 a x e to the x minus 5a e to the x plus 4 a e to the x equal 8 e to the x. All right. Now, okay. If we go back to just the e to the x terms, I think we're okay. All right. Let's combine like terms, the ones with the x's in them, and we only have two of them. That gives you what? Minus 4a x e to the x plus, now let's do the ones without the x in them, and what does that give you? Plus a e to the x, right? Is equal to 8 e to the x. All right. Now, here we have a problem, Houston. Oh, I messed up. Sorry, wait. I knew this wasn't coming out right. Okay, forget most of this that we just did. I saw an error. I can't get it to erase because it's trying to shame me here. Okay, our YP has an X in it and I left it off. Okay, this has an X in it here. When I was looking at it, I thought, where is that? And now with those with the X in them, we have a e to the x minus 5a e to the x plus 4a to the x e to the x. What does that add to? Zero, which is very good because you don't have any x's over there. So those disappear. Now let's do the only two that are left here with the a e to the x only. What do we have here? Negative 3 a e to the x is equal to 8 e to the x. What does that suggest to you? Negative 3a must equal 8 because you could just divide out those, right? So what would a be? Negative 8/3, right? All right. Got it. So there's our particular solution. Y sub p must be negative 8/3, that's a, x e to the x. Okay? Then our general solution, y, is going to be our yc plus our yp, and that's going to be c1 e to the 4x plus c2 e to the x minus 8/3 x e to the x. All right, so there is our solution. Two parameter system, and because it was second order differential equation, and sure enough, that's it. So the difference, all right, they didn't write out the total answer, we did. Okay. Now, the difference in the procedures used in 1 through 3 and 4 is that suggests we have two cases. The first case reflects the situation 1 through 3. No function in the assumed particular solution is a solution of the associated homogeneous differential equation. That's what we did the first three. That was last time. And that worked quite nicely. Okay, in table 441, we illustrate some specific examples of the g of x in that equation way back on page 139 in the yellow box there, our general higher order differential equation with constant coefficients. Okay? Along with the corresponding form of a particular solution, we are, of course, taking for granted that no function in the assumed particular solution y sub p is duplicated by a function in the complementary function y sub c. So here are the trial particular solutions. Now, do all of you have text? Yeah, you do. I'm trying to think, do the people not here also have text? No, one of them I think maybe not. So let me write these out just in case he doesn't have this text. He does. Oh, fantastic. Okay, this is your table here. I'm wondering if it might not be worthwhile to do anyway, so I think I will. Okay. Here's your g of x. This is the thing in your higher order differential equation, the right-hand side, the functions of x. And here's your y sub p that you might use to do. So, first is any constant. They put 1. I'm just going to put k. Any constant k, then the y sub p would be any variable a, okay? Or parameter a, I guess you would say, okay? If you have, as your g of x, a linear function, say 5x plus 7, but that could be any coefficients there at all. It doesn't have to be those. Then use ax plus b. That makes sense, doesn't it? Okay. 3, if you had a quadratic, x cubed, it's not a quadratic, a 3-term polynomial, minus x plus 1, for example, then you would have to have an ax cubed plus bx squared plus cx plus d. Okay? At least every power you have in may be skipping. Okay? And they left off, and again they do this, and there is a reason for it. Not clear yet what the reason is, but they don't use the symbol D, they use the symbol, my thing, right when I'm writing, it collapses, okay. They use E. Now the reason for that, D is used as a differential operator, so they don't use the symbol D. So, now, number 4, that was 4. Oh, I skipped 3. This was 4. Okay. 3 was the quadratic, I thought it was, 3x squared minus 2. Okay. Then you would use an ax squared plus bx plus c. Okay. Any quadratic, but allow one for every term, even ones you may have skipped before. Now, with the quadratics, with the polynomials, keep going. If this were to the 7th power, then do 1 for each term with the 7th, okay? You match your y sub p with the most generic form of something that corresponds to your particular solution. So if that was just a y to the 7th, if that's all you had here, you would still do ax, x to the 7th here. It would be ax to the 7th plus bx to the 6th plus cx to the 5th plus ex to the 4th plus fx to the 3rd plus gx to the 2nd plus, you go down and accomplish every term that you have, okay? Any polynomial, you follow that pattern, okay? So that calls your polynomials. Okay, what if you had, number 5, was either a sine, say 4x, or a cosine 4x. I'm combining two of these together. Either sine 4x or cosine 4x. Now, I just pulled 4x out of the blue. It could be any multiple of that. I mean, any coefficient. You know, x, 7x, 4/3 x, whatever. Okay? On both of these, you would use an a cosine 4x plus b sine 4x. Okay? That's what we use for any one that had either a sine or a cosine or both, then use that. Okay? Now, if they had a sine 4x plus the cosine 5x, then you would need to have a cosine 4x plus b sine 4x, e cosine 5x plus f cosine 6 of 5x. You would have to have one for every different argument that you would have there. Okay, I'm combining some of these. Okay, number 7. This is 6 and 7, 5 and 6. Number 7. That's 5. This is 6. Okay. Number 7. E to the 5x, or anything there. E to the 5x. Now, this is the one you have to watch out for. If your characteristic equation came out with an e to the 5x, then you've got to do case 2. We're not doing case 2. Doing case 1 where there aren't any of those. So as long as you didn't have a 5x in your particular characteristic equation, you can go with this, and then you would use a e to the 5x over here. Okay? Just straightforward. Number 8. What if you had a combination of polynomial functions multiplied by a product of polynomial functions and exponential functions, such as 9x minus 2 times e to the 5x. They seem to like e to the 5x. Well, then what would you have here? You would have a x plus b plus c e to the 5x. Okay? That should do it for you. Well, they put parentheses around there. That would be perfectly fine. Okay? No. Wait. I'm sorry, I'm looking at the wrong thing. Okay. ax plus c plus b times e to the 5x. Okay. Now, this, remember, is the same as ax e to the 5x plus b e to the 5x, which covers anything you need here. This is the generic form of that, and e to the 5x has to be that. But again, remember, that can't be part of your characteristics. E to the 5x cannot be. Okay. All right. Number 9, and this is just one. It's not any better or worse than the other. X squared, or any quadratic function that could have x terms in it, constant terms in it. It doesn't matter. But x squared e to the 5x. Then you have to have in your polynomial part the most generic quadratic, which would be ax squared plus bx plus c times e to the 5x. Okay. Goodness gracious, this thing is aggravating. Okay. And carrying on down like this, any polynomial you multiply by exponential, then if that polynomial is to the 14th power,
then you would have to have an AX to the 14th plus BX to the 13th plus CX to the 12th plus EX to the 11th, but on down, multiplied by that E to the 5. So the polynomial is just like before, you have to account for every term. Okay. Now, the next possibility, if you combine 7 with 5 or 6, okay? In other words, this will be number 10 here. And number 10 here would be e to the 3x. Finally, they got off the 5x. E to the 3x sine 4x, but they stayed on 4x, okay? Sine 4x, okay? Well, you would need, goodness gracious, it doesn't matter in which order you put them, but you would need some a, e to the 3x, and I guess they put cosine first, it really doesn't matter, cosine 4x plus b e to the 3x sine 4x. Okay? Now, again, you have a product function here. You must have the same products here, except remember, anytime you had either a sine or a cosine, you have to include both a sine or a cosine on that part. Both. Not either or, not one, both. And if these are to the same, these have to be the same power. Okay? The e to the 3x, or whatever your exponential function, has to be multiplied by each of those. I'm running out of room, so I'm going to come over here and do the same thing here. Number 11, okay, is 5x squared e to the 4x, sine e to the 4x. 5x squared sine 4x, okay? You tell me what you think this one would be. AX squared. Okay. You might write it that way, but I like to go and do the whole polynomial. Plus BX plus C. That's your polynomial part. Times, yeah, doesn't matter which one you do first. Cosine is fine. Cosine 4x plus sine 4x. Okay. Now let's see if that's how they do it. Not quite. Okay. Because it doesn't have to be the same coefficient there, this is multiply this, and here you have a e x squared plus fx plus g times the sine of 4x. Okay, so a little more involved here. You have to include all the possibilities of your polynomial function with cosine, and then another series of possibilities with polynomial function with the sine. Which, I think this may have been the way Silver was starting to have done, but you could have done that. This is getting the same thing. AX squared times a, no, it wouldn't apply. So rather than combining these, let's see. You could have done it this way. If x squared times a cosine plus b sine plus a x times c, yeah. As long as you get all the ones there, you could do them that way. In other words, do the polynomials separately times your sines, your trigoons, or do your trigoons together with a's, b's, still wouldn't work. This one with a x. This is probably the best way to do it. Just stick with that. You could conceivably do the other, but yeah, what I was going to say was X for A and B here, X with C and a D and an E here, and a constant term, say 1, with a alpha and a G there. And you would come out basically pretty close to the same thing. But that probably is the simplest way rather than muddying the waters in it. So that was 11. How about 12? 12 was an x e to the 3x cosine 4x. They like that 4x, don't they? Okay, you tell me what function you think they would have to have here. Okay, your polynomial would have to have an ax plus b at least, right? Okay, now the e to the 3x is not much you need to do with that. E to the 3x, okay? Right, okay. Well, but let's do them separately. Cosine 4x here, just like we did before, let your polynomial carry your constants and just throw in the others as you need them, okay? Strange way to say it. Goodness gracious, this writing is terrible. Plus, and then here you would have a cx plus e to the 3x sine 4x. Okay. Yeah. Have the constants with the polynomial part, but then you have to have the other functions in there, both for sine and cosine with different polynomial functions in front. All right, that's your case 1 here. So now let's look at example 5. Goodness gracious. All right. Determine the form of the particular solution of these. In other words, they're not saying we have to solve it, or at least that's how I read it. This is a y double prime minus 8y prime plus 25y is equal to 5x cubed e to the minus x minus 7, wait, yeah, there it is, minus 7 e to the minus x. And all they're asking for, determine the form of a particular solution. Now, there's a part of me that doesn't even want to mention this part, but then another part says, yeah, you got to. What's that? Yes, it is. Okay, that's very similar to number 9. Not quite the same, but pretty close. In fact, if you factored out the 5x cubed minus 7 and put that times e to the minus x, you would have something even closer to that. Because those are the same values for x. So in fact, I think I'll do that. To me, that's just a much neater way of writing that. 5x cubed minus 7 e to the minus x. Now, if that had been one of those e to the minus x, the other e to the minus 2x, or something like that, then, yeah, you have to keep them separate, okay? But they were the same, e to the minus x, unless I copied it wrong. No, I don't think so. So that's how I'd write it, and now that's pretty similar to, actually more similar to 8, in effect, right?
But what would be your particular solution? Y sub p. What would be your first best guess? A x to the third plus bx squared plus cx plus e. Got it. Okay? Now, yeah, e to the minus x on the outside. Now, let's go back to the scenario I was saying, what if it was this? What if this were 7e to the minus 2x? Any other thing other than minus x. This would have still been required for this one. But then you would have had, then, if this is just a 7, then you have a plus f e to the 2x or whatever. Okay, minus 2x, whatever that other one was. You would just have to have one for that one as well. Okay. But this will be adequate here. Let's see what they got. Y particular would be ax cubed plus bx squared plus cx plus e times e to the minus x. Very good. Now the b part here said, what if you have y double prime plus 4y is equal to x cosine x? All they're looking for is the particular solution. What would you use then? A little louder. It's not really all that hard. What would you get? Second, A. What's that? AX. I think you have to put a plus B in there too to account for every term. Okay. Times second cosine x, that would be fine. Plus cx plus e. I say e and write b. Okay, I don't know what's going on. Sine x. Okay? That, I think, will do it for us. Let me... Okay. Whew. All right. Clogging up again. All right, let's see what they got. Oh. Yeah, I know, but I was trying to read what they have next. On that previous one, it says there is no duplication between the terms of y sub p and the terms of... Okay. All right. I don't see... sorry, I'm getting... I'm having trouble finding where they get at the very bottom of that page. Note that there is no duplication between the terms of y sub p and the terms of the complementary function y sub c is equal to e to the 4x times c1 cosine 3x plus c2 sine 3x, sorry. Where did that come from? Neither one of A or B up there has an e to the 4x in it. Okay? Oh, the B one, yeah. Okay, got it. The B one, okay, that's where, this one right here, okay, got it. Your characteristic equation with the m's is m squared plus 4 equals 0. You know, when you do the, yeah. And this would be m is equal to plus or minus 2i, right? Okay. Now, that's where it comes from. Because then when we do the sine and cosine that corresponds to that, if you go back to the previous section, that was your case 3 conjugate complex roots, okay? Your e to the IB, e to the I beta x, and e to the minus I beta x. Well, let's see, let's just not even do those. Skip over to the final, okay? Your your real part is 0, okay? So I still don't see where they get it. And your imaginary part is e to the alpha x cosine and sine beta x, where beta is the imaginary part. Well, that's 2i. Where do they get to the e to the alpha x? Where do they get that being e to the 4? I do not see it. Wait, this must be the first one, because the 3 x's are wrong. That would be a 2x. So I'm still not seeing that. I thought I had seen it, but no, I don't. Let's do the characteristic equation of that first one. M squared minus 8m plus 25 that would be m is equal to minus 8 or plus 8 plus or minus the square root of 64 minus 100 over 2, right? This will be 4. That's where it came from. The A part, not the B part. Okay. That's 4 plus or minus, and this would be 36. Square root of 36 is 6. Half of that is 3. 3i. Got it. That's where it came from. Your e to the 4x comes from this part, and your sine and cosine of 3x's come from that part. Okay. Now, so back on this one here, because your e to the 4x came from there, this has e to the minus x, no problem there, and then sines and cosines have no duplication there. So that one was from the A part. Okay, sorry about that. The B part then is what we just said, ax plus b cosine x plus cx plus e sine x. Again, observe there's no duplication between, this one doesn't have an e to the part because this is just, this part would produce I'll put the C1 in it. C1 cosine 2x plus C2 cosine 2, sine 2x. Okay. It doesn't have an e part because there was no real part in that solution. It's just plus or minus 2i. So that, therefore it has that. So yeah, and that's what they got. C1 cosine 2x plus C2 sine 2x. Got it. Okay. If the G consists of a sum, say, of m terms of the kind listed in the table, then, as in example 3, the assumption of a particular solution y sub p consists of the sum of the trial forms P1, P2, P3, all those added together. And the foregoing sentence can be put another way. The form rule for case 1. If the form of y sub p is a linear combination of all linearly independent functions that are generated by repeated differentiation, of g of x, the form of y sub p is a linear combination of all the linearly independent functions that are generated by repeated differentiation of g. Okay. So let's do example 6. Goodness gracious, I'm getting a headache with this stuff. It's been on and off all day, just right here, just gets almost throbbing. Again, we're looking for a form of a particular solution. We're not going to mess, well, we are. They did before. Y double prime minus 9y prime plus 14y is equal to 3x squared minus 5 sine 2x, my nose is itching, plus 7x e to the 6x. All right, did they not want to confuse the issue here? Okay. Now, since they did it before, they're going to do it again, so let's go on and head them off at the pass. Let's do the m equation. What would that be? M squared second. I can't hear you. Yeah, m, I'm sorry. I meant to write it, just didn't carry over. Okay? Got it? Now, think that'll factor? What?
Yes.
What?
-7.
-2. So that would give us yc equal c1 e to, which one you want to put first? I don't care. -7x plus C2E. What's that?
It's going to be positive, right? When you,
Oh, yeah. Okay. E to the 2x. All right, because m equal 2 and m equals 7, right? Okay? Now, take a look to the right. We don't have a 7x or a 2x, either of those, so we're going to be fine. So they waited to the end to do it. Let's go and do it again. All right, now you get the form of a particular solution. What's going to start it? I'm sorry? Yeah. A x squared plus bx plus c. Okay, that's going to be your polynomial part. Okay? Next. Okay. Now notice this is not multiplied, these are summed. Okay? Not multiplied, summed. Those in the table were things multiplied together. So, and this is based on what they said here at the end. When you have multiple p's, then combine the p's together. Okay? Okay? So, that would be the first one. What would be the next one? Let's do this part. Second? E. Let's use E. They don't like these. Okay. Cosine 2x plus f sine 2x. Okay. That's going to be this part. Okay. And then how about the next one? Okay, I couldn't hear it. Did you say G? Gx plus h, got to include every term in the polynomial, e to the 6x. All right, I'm hoping that's going to be it. Let's see if we got. The yp1 is your first one, ax squared plus bx plus c. Your yp2 is going to be the second part, e cosine 2x plus f sine 2x. And then your yp3 is the gx plus h, e to the 6. And you add them all together, and you get exactly what we got here. Ax squared plus bx plus c plus e cosine 2x plus f sine 2x plus g plus h, gx plus h, e to the 6x. Got it. And no term duplicates any of the, either the e to the 2x or e to the 7x. So we're fine. Now we're ready for case 2. I don't think we're going to have time for case 2, do you? Okay, so let me move my arrow down here to be case 2. And that's what we'll pick up next time. Homework exercises in 4.4. You can do any of the odds, I think 1 through 25. And if you can't do all those toward the end, you might just wait a minute until we do a few more examples, because it looks like they may have some case 2s in there. So any case 2s you run into, if you can't work them, don't sweat them, go later. And then we'll work on the initial value problems later. So next time, we will continue and hopefully finish 4.4. We're going to skip 4.5 because 4.5 is just another technique for doing undetermined coefficients called the annihilator approach. Since we've done undetermined coefficients with the superposition, we're not going to do annihilator. You can read through it. If you like that better, go for it. And hopefully we'll get started on 4.6, variation of parameters. that goes back and ties something we did earlier to what we're doing now, and can get a little on the complicated side, but it usually works out pretty smoothly, usually. And that's a very short section. If we have time, we'll do Cauchy-Euler equation. I kind of doubt we'll get there, but we'll try if we can get there. And that's 4.7. Unfortunately, I haven't made it to Green's function yet, and we're not going to get there this time. But I know, knock on wood, we should get into 4.6. So I'll try to have your final exam ready for you. It's your last test, which is basically going to be Chapter 4, as much as we got covered in it. And I'll have that ready for you on Wednesday. I'm going to try to put something together for De Silva now, because she's got to leave town sooner than you guys do, so I'll try to find it. So, yeah. What's that? Oh, that she had to leave town? Yeah. Okay. So I'll try to get that done. All right, let's, what's that? Am I?
Are you going to give me the test today?
Yeah, I'm going to see if I'm pretty sure I've got this one made out. I may have to eliminate some problems, but I think I've got it made out. It's the other one I've got to piece together, and I'll try to get that done too.
I'll